let's do some practice problems from 8.2, starting with number 9. Number 9 says that a sub n is given by 8 plus 13n. If I want to find the nth term, just plug n in there. Fifth term is going to be a sub 5, put a 5 in there, and calculate away. They want us to find the first 5 terms, so the first term would be a sub 1. So we put a 1 in here. 8 plus 13 times 1, that's 8 plus 13. That's going to be 21. Okay, next we put a sub 2. 2 in for n, so 2 goes in here for this n. So 8 plus 26. Well, 26 plus 8 would be 34. Okay. Now we could use the formula, keep on using the formula, put in a 3, and then a 4, and then a 5. Or we could remember this is an arithmetic sequence. That means that we add the same number every time. It's kind of the common difference. So if we add 13 to 34, then we'll get 47. Do that again, add 13 to 47, and you'll get 60. Add 13 to 60, and you'll get 73. And that's the first 5 terms. Let's go to 16. A sub n is given by 3 minus 4 times n plus 6. Okay, so a sub 1 would be when we put a 1 in here for n. So 1 plus 6, that's going to be, let me make sure I've written this down right. Yeah, this is plus 6. So 1 plus 6, that's 7. 7 times 4, well, that's going to be 28. And this is going to make it negative, so negative 28. 3 minus 28 is going to be negative 25. Now we could keep doing this. We could keep putting in a 2, and then a 3, and then a 4. But we could also change this a little bit so it looks more like this formula, and then we would know the common difference, and we could just keep adding that on. So let's see if we can figure out what that is. Well, all we have to do is distribute this negative 4, and then we'll just put together like terms, and we should have something more useful. So this is going to be 3, negative 4 times n is negative 4n. Then negative 4 times 6 is a negative 24. So put the negative 24 and the 3 together, and you'll get negative 21 and still minus 4n. And that's exactly what we have here. Negative 25 is negative 21 minus 4 times 1. That's negative 25. Now we know the common difference is negative 4, and we're going to keep subtracting 4. So this is going to be negative 29, negative 33, negative 37, and negative 41. Just keep subtracting 4 from each term. Okay. So if you see a formula for a sub n, you will be able to distribute something, rearrange some things, get it to be in the form of a sub 0 plus d times n, d being the common difference. Number 17. A sub 1 is equal to 1, and d is equal to 3. And they want me to find a sub n. Is that it? Yeah, a sub n is all they want us to find. Well, remember the formula for a sub n is a sub 0 plus the common difference times the term you're on. Whether you're on the first or the second or the third or 17th term, that's what n is. So a sub n for this one is equal to, what's a sub 0? A sub 0 is the term before a sub 1. Here's a sub 1. Just before that would be a sub 0. Just after a sub 1 would be a sub 2. Right? We follow that progression of a sub 1, a sub 2, a sub 3, so we can go backwards. A sub 0, a sub negative 1, a sub negative 2. Okay, so a sub 0 is this guy just before this number 1. How would we find that? Well, if I wanted to get from 1 to the next one, I'd add 3. Add 3 to get 4, add 3 next time to get 7, and so on. So to get to the term before it, then I would subtract 3. So 1 minus 3, that's negative 2. There we go. There's a sub 0. Plus d, they give us, is 3 times n. And we're done. How about number 22? 22 is 10, 5, 0, negative 5, negative 10. Okay, remembering our formula is going to apply to every arithmetic sequence. A sub n is equal to a sub 0. Okay, a sub 0 would be this guy right here. Well, I noticed that I'm going to subtract 5, subtract 5, subtract 5. This gives me my next term. So the term before this one must have been 15. If I subtract 5 from it to get 10, it must be 15. So 15 plus d. What's d? What do I add? Not just what do I do, but what do I add? What number do I add to get from 10 to 5, from 5 to 0, and so on? I add a negative 5, so d is negative 5. So if I'm going to add negative 5, I'll just subtract 5 times n. And there we have it. Let's do one more like that. 25. 25 says that a sub 3 is equal to 94. Here's a trickier one. And a sub 6 is equal to 85. Okay. So now they don't give us a sub 1. They don't give us d. They don't give us the sequence written out. They just give us two terms, like right in the middle of the sequence. How are we going to figure this out? Well, we should realize that we have a sub 3. They give us that, right? That's 94. And they give us a sub 6. That's 85. What they don't give us are the terms in between. That's a sub 4 and a sub 5. Okay? How do we get from 94 to 85? Well, to get from 94 to a sub 4, I'm going to add a number. What is that number? Well, let's just call it d for now. Add d. You're going to add d again to get from this term to that term. And then you're going to add d another time to get from here to 85. So 85 is equal to 94 plus all these steps of d. How many d's are there? There's 1, 2, 3. If I add on 3 of the common differences to 94, then I'll get 85. Now I can solve for d. Okay, let's do that. See why that might help us. So 85 minus 94 is negative, let's see, negative 9. Let me make sure I'm right on that. Yeah, negative 9. And that equals 3d. So d must be equal to negative 3. Divide by 3 on both sides, you get negative 3. So d is negative 3. So that's nice. What do I do with that, though? I need to have a formula of a sub n equals a sub 0 plus d times n. So I have d, but I don't have a sub 1 or a sub 0. Well, let's go back to a sub 0. Here's a sub 2, a sub 1, and this would be a sub 0. So if I subtract d, right, going this direction would be subtracting d, subtract d, subtract d. So I subtract d 1, 2, 3 times from 94. We're going to kind of separate our work here. This is going to get a lot more space. If I take 94 and I subtract 3 times d, and we just found d to be negative 3, then I'm going to get a sub 0. Right? A sub 0 was the most convenient thing to find since we need it to put in our formula. So this is 94. Negative 3 times negative 3 would be a positive 9. This equals 103. That's a sub 0. So our formula then, a sub n, is equal to a sub n is equal to a sub 0, which is 103, plus d, so the minus is a negative, so minus 3 times n. So there's our formula for number 25. Let's go with number 35. Number 35, they give us a sub 1 is equal to 15. A sub k plus 1 is equal to a sub k plus 4. They want us to find the first 5 terms, find the common difference, and then write the formula for a sub n. Find the nth term. So first, let's write the first 5 terms. Here's the first term, 15. But what's the next term? The thing that throws people sometimes is this. You just throw these random variables down here. Sometimes it's n, sometimes it's I, sometimes it's k. But all it means is think about the sequence. I've got a sub 1, and it's 15, and then I go along, and here I come somewhere in the middle is a sub k. Maybe it's a sub 17 or a sub 55, or I don't know. But it's something. It's a sub some number. Well, what's the term? I guess I'll just say a sub k. So here's a sub k. What's the term after a sub k? Well, if it were a sub 3, the next term would be a sub 4. If it were a sub 7, it would be a sub 8 would become next. If it was a sub 1 million, it would be a sub 1,000,001. It's just something 1 bigger than k. So, pardon me. The next term is going to be a sub k plus 1. Okay, so all this means is to find a sub k plus 1, take a sub k, and add 4. Okay, so if I want to find this next term, take the term before it, 15, and add 4, that's 19. If I want to get from 19 to the next term, then I just add 4 again. So 19 plus 4 is 23. If we keep going to this, 23 plus 4 would be 27. Add 4 again, and we get 31. All right. Let's see. Next, let's do number 40. It's a slightly different kind of a problem. They say that the first two terms are given, and what they want us to find in this problem is a sub 9. Okay. Now remembering that our little formula is that a sub n equals a sub 0 plus the difference, the common difference, times n. So first, well, it's not necessarily first, but one of the things that we do need to do is find the common difference. So here's the first term, here's the second term. What must be the common difference? Well, 13 minus 3, that's 10. So the common difference is 10. So that's part of it. A sub n is equal to a sub 0 plus d, which is 10 times n. So now we just need to find a sub 0. A sub 0 is the one before a sub 1. Right? Something came before a sub 1 where I would have added 10 to get to 3. So what's that going to be? That would be negative 7. A sub 0 would equal negative 7. So a sub n equals negative 7 plus 10n. So a sub 9 equals negative 7 plus 10 times 9. And this would be 90 minus 7, or 83. So there is the 9th term in that sequence. Okay, number 53. Says, find the sum of the finite arithmetic sequence. So they give us 2 plus 4 plus 6 plus 8, and so on up till 20. Following that pattern, it looks like they're adding 2, adding 2, adding 2, and they add 2 all the way up to 20. Okay. Now remember that the formula for the finite sequence, when you let I equal 1 to n of this rule, if you can find these things and write it this way, then that's going to be a sub 1 plus a sub n, the first term plus the last term, times the number of terms, that's n over 2. Okay, so this one is I equals 1 to, how many terms is that? We can just look at them. 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. There's 10 of them. So, well, let's see. We're going to 10 here. The rule is going to be, what's a sub 0? What I have to add 2 to 0. Plus, the common difference would be 2, clearly, times n. So this is a sub 1 would be 2, plus a sub n, a sub 10, that would be 20, times the number of terms, that's 10, over 2, that's 22 times 5, or 2, let's see, 220 by 2, be 110. 110.